Case study historical sales and 2025 forecast, line graph. Pradeep K. Suri. Author, researcher, and AI/ML architect. 1. Historical sales and 2025 forecast, line graph. Description. X-axis, years. The x-axis represents the timeline from 2015 to 2025. Y-axis, sales. The y-axis measures sales figures ranging from 2,000 to 4,500 million INR. Data points. 2015, sales start at approximately 3,500 million INR. 2016, sales peak at about 4,000 million INR. 2017, a sharp decline brings sales down to around 2,000 million INR. 2018 to 2019, sales stabilize around 2,500 million INR. 2020, sales rise again to nearly 4,000 million INR. 2021 to 2022, another decline drops sales to about 2,500 million INR. 2023 to 2024, sales slightly increase to around 3,000 million INR. 2025, a forecasted data point indicates a slight increase, reaching around 3,200 million INR. Key insights. Fluctuations. The line graph shows significant fluctuations, with periods of both sharp decline and substantial recovery. Stabilization periods. After the initial decline in 2017, sales stabilize for a couple of years before rising again. Forecast for 2025. The forecast predicts a modest increase in sales, suggesting cautious optimism for future growth. 2. Sankey diagram of sales fluctuations, 2015 to 2025. Description. Representation of sales changes. Start, 2015. The initial baseline of sales is represented in blue. Peak, 2016. A notable peak in sales is also marked in blue. Trough, 2017. The lowest point in sales is highlighted in red. Stabilization, 2018 to 2019. A period of steady sales, represented in yellow. Recovery, 2020. A significant recovery in sales is shown in green. Drop, 2021 to 2022. Another decline in sales, also in green. Slight increase, 2023 to 2024. A gradual increase in sales, continuing in green. Forecast, 2025. The predicted sales for 2025 are represented by a green segment. Key insights. Visual flow of sales. The diagram visually represents the flow of sales over the years, with the width of the segments indicating the volume of sales changes. Periods of change. It effectively highlights key periods such as peaks, troughs, stabilization, and recovery. Future outlook. The forecasted increase for 2025 provides a visual cue for expected trends. Combined insights. These two visualizations together provide a comprehensive view of the sales trends and forecasts over a decade. The line graph offers a clear view of the yearly fluctuations, while the Sankey diagram provides a broader overview of sales changes and their relative impacts. By understanding these visual elements, stakeholders can better analyze past performance, identify patterns, and make informed decisions for future. K-fold random forest. Case study AI model design, random forest explanation. A random forest is an ensemble learning method used for classification, regression, and other tasks that operate by constructing multiple decision trees during training and outputting the class that is the mode of the classes, classification, or mean prediction, regression, of the individual trees. Here is a detailed explanation. 7 decision trees. Description. A decision tree is a flowchart-like structure where an internal node represents a feature, or attribute, the branch represents a decision rule, and each leaf node represents the outcome. The paths from the root to the leaf represent classification rules. Example, think of it as a series of questions that guide you to a final decision. For instance, deciding whether to play tennis based on weather conditions, sunny, rainy, or overcast. 8. Ensemble method. Description. Random forest is an ensemble method, meaning it combines the predictions of multiple machine learning algorithms to make a more accurate prediction than any individual model. Benefit. This reduces the risk of overfitting compared to a single decision tree and increases the model's robustness. 9. Bagging, bootstrap aggregating. Description: Random forest uses a technique called bagging. It involves creating multiple subsets of the original dataset with replacement, bootstrap samples, and training a decision tree on each subset. Benefit: this helps in reducing variance and avoiding overfitting. 10. Random feature selection. Description: at each split in the decision tree, a random subset of features is considered for splitting. Benefit: this randomness helps in making the trees less correlated and improves the overall performance of the model. 11. Voting/averaging. Description: for classification tasks, the random forest takes the majority vote of the predictions from all the individual trees. For regression tasks, it takes the average of the predictions. Example: if most trees predict yes for playing tennis, the random forest will predict yes. 12. Feature importance. Description: random forest can be used to rank the importance of variables in a regression or classification problem. This is done by measuring the decrease in the model's performance when the values of a particular feature are randomly permitted. Benefit: it provides insights into which features are most influential in making predictions. Image description. The image is a visualization of feature importance in a random forest model using k-fold cross-validation. The features are listed on the left side: petal length, cm, petal width, cm, sepal length, cm, and sepal width, cm. The width of the red bars represents the importance of each feature, with petal length and petal width being the most important, and sepal length and sepal width being less important. Summary: petal length, cm most important feature. Petal width, cm also, highly important. Sepal length, cm less important. Sepal width, cm least important. This visualization is crucial for understanding the contribution of each feature to the model's predictions, allowing for better model interpretation and improvement. Thank you.